Uh, Hi, I can hear you fine.
Yes, I can hear
Okay,
you too. So you
thank
can
you
go
very
ahead,
much.
Olan.
Yeah, my name is Olymp Niragira. I am a radio frequency engineer at Trans-Africa Communications, which is an ISP based in Kigali, Rwanda. And uh, since like 5 to 6 months, we've started discussions with Mr. Cedric Adrien from Afrinic on the way we could start a, a network operators group in Burundi. Although I'm based in Rwanda, I'm from Burundi, and I believe that actually we need to gather together. We need to have a community of engineers that can help one another, and then also be able to support the digital initiative that is undergoing in Burundi, develop the telecommunication sector, and also have affordable internet prices. And this is usually through collaboration, partnership, and also as well as knowledge exchange, just to be able to know what are the trends in technology. And then that's the reason why we took this step ahead and started this community, which that we called Burundi Network Operators Group, or BNOG. Yeah, it's in existence since few months, 6 months. And this is our first webinar, knowledge exchange. So actually, Mr. Nishal, you have the privilege to initiate this initiative for our country. So thank you very much for your time, your passion. So we are eager to learn from you, to exchange, and then be able to develop our community. Yeah, thank you very much.
Thank you. Thank you for that very warm welcome and congratulations is in order immediately, because if this is your very first meetup, you've managed to get a bunch of folks online. You've managed to get interested people online to talk about a simple part of technology, I think, but a most crucial part of technology to helping to fix your country and to move forward. So again, my congratulations. I hope that this is not the first. I've helped many NOGs before, as has Cedric also on the call. And it's very exciting, I can tell you from my part, to be the first. So again, thank you from my side for allowing me the honor of being your first speaker. But it's also
Yes,
very exciting to see NOGs grow. And I guess you can't see me. I'm quite old now. I've been doing this for a long time. But it's
yes,
really exciting to see the difference that a NOG makes in a country.
yes,
And I'm thrilled to hear that you guys are now doing this for Burundi, and you have my help. I work for Packet Clearinghouse. On the call, I think,
yes,
is also Sarah. I don't know if
yes,
she's connected yet. And one of the things that we do is we help NOGs. So aside from giving you this talk today about internet exchanges, we're very happy to
yes,
support you to grow and build your NOG how you see fit. Cedric and Bashir are here from Afrinic. I think I can take a moment to say that Afrinic also does exactly the same thing. They're here to support you and they're here to help you. Because we have the same mission, really, and that's it, to be able to empower the African community. We help in
yes,
various ways, and really not the time to talk about that.
yes,
But we're here to help you. But we're here to help you to get to the next step and to get beyond the next step. But taking those first few steps and carrying the work out on the ground, unfortunately, that's your new. You need to be able to do that, but know that you've got good people willing to help you and support you. Some of us even in our own personal time. So my congratulations to you again.
thank
Today,
you, thank you.
you asked me to talk about internet exchange points and how internet exchange points work and why they work. I'm going to do that. You've given me a lot of time to do that, so thank you. But I also want to try to change your mind a bit. When you learned about internet exchange points, when you learned about IXPs and interconnection, you were told many years ago that this is a very complex technical thing. You were told many years ago that if you're going to want to connect to an exchange point or you want to use an internet exchange point, then you need to get lots of things done. It's not easy. You need to go to Afrinic, you need to fight with Afrinic, you need to get IP resources from Afrinic, and Afrinic are difficult to deal with, and they're going to take up a lot of your time. And then once you've got those resources from Afrinic, then you need to go and hire very expensive BGP network engineers, somebody who's got 20 years of experience, and those people are not cheap. They're going to charge you a lot of money. And then they're going to connect your network to the exchange, and they're going to reconfigure your network, and there will be an outage, and there will be downtime. Your business will go offline. That's probably what some of you would have heard, some variant of that. Maybe you didn't hear the part about your business going offline, but I'm willing to bet that the rest of the story, the part about the Afrinic being difficult to deal with, and you need expensive BGP engineers, and BGP is very, very technical. Everybody says this. BGP is very, very technical. If you do the wrong thing, you'll break your network. Well, that's true, right? BGP is a technical thing. If you do the wrong thing, you will break your network. But, driving on a road is a technical thing. If you do the wrong thing on the road, you stand a good chance to do worse than break your network. You might break your life. So I'm going to share a secret with you today, which is something I usually don't do with NOG operators. I know BGP. I know BGP for about 20 years. We've loved each other. We've fought each other. I've known BGP longer than I had been married. I was married for 3 years only. My marriage did not survive. I'm now divorced. But BGP and I have had a love relationship, and I'm saying love, not hate. We have had a love relationship for 25 years now. So BGP and I work well together. But my dirty secret is that I don't know how to drive a car. I don't have a driver's license. Cedric is laughing. Ask him. Whenever Cedric sees me, Cedric is usually the one that gets me a taxi or he drives me around town. So if you think BGP and peering are difficult and you think driving is easy, what's the difference? Well, you've gone through a regiment. You went through a school where you learned how to drive. You didn't wake up in the morning and then go on the road and immediately start driving. And I hope not. I hope not. I hope you've gotten a license, did the test, whatever order, and now you know how to drive. It's the same with BGP. Although there's no driver's license that's afforded, there's schools, there's colleges, there's training from NOGs like these, where you can learn BGP. And once you know BGP, applying those principles are really, really simple. It's a few things that you need to worry about. And if you can do that right, your peering will work just fine. And no, it will not break. I can tell you this as someone who has this love relationship with BGP for 25 years. If you apply BGP using the rules that we can teach you, you don't have to worry about your peering again. You said Rwanda. I was first in Rwanda in about 2000 and I don't remember 10, I think, where we taught network engineers BGP. And I can tell you that configuration that we helped the network engineers put onto their devices in Rwanda is still working today. The guys haven't changed it because their network hasn't changed, and there's no reason for them to change what they have to the exchange point. So although we're not going to be teaching you about BGP on this call, I'm going to want you to think about network and peering differently. Remember what I'm saying, that don't be scared. It's just something that you haven't touched before. And the people that are telling you need special skills to learn BGP are completely incorrect. All you need is time, energy, and someone to point you on the right path. But today I want to talk about a different part about peering. I don't want to talk about BGP, because we can do that in a different class. And since this is a NOG and hopefully it's going to happen all the time, maybe we can make a class in the future, a BGP training class. Well, 3 or 4 BGP training classes. Today, I want to talk to you about why peering matters. And let's see if I can get the screen sharing thing to work. If I get the screen sharing thing to work, you should soon be able to see my slides.
We can see your slides.
Yes, but I can't see my slides. The wonders of technology mean that you can see what I'm talking about, but I can't see what I'm talking about. I'm going to start that again. Give me a second. Screen share. There we go. Hopefully that works. Does that work?
Yes, all good.
Yes, yes.
All right, fantastic. So today I want to talk to you about why peering matters. And I hope you can read the slides. I hope you can see the slides and you're not connecting only via your phone or reading audio, because I'm going to refer to parts of it. And I'd like you to pay attention to that bits. I trained as an economist. It's true. I trained as an economist. Ask me something about fiscal policy, ask me something about balance of payments, ask me something about country economies. That's my thing, right? But I decided that I wanted to spend 2 years figuring out what this internet service provider thing was like. So I got a job at an ISP, working in their call center. After 6 months, I was running their call center. And after a year, I didn't look back. I decided that this was the thing for me. So I'm my background is supposed to be economics. I'm trained as that, but I've never ever done a day's work of economics in my life. So it's not a good idea to listen to me about economics in particular, since I have zero training. But I do, zero background. But I do have the training. But I do know the internet stuff, because that's where I've spent my life for the past 25, 26 years doing and working in this field. And today, what I want to talk to you about is actually a mix of both. It's about how common sense ideas make it into what we should expect to do on the internet on a daily basis, and how those common sense ideas, what you and I might think, oh yeah, we should do it because it feels like it's the right thing, how those common sense ideas translate into real economic decisions that impact your economy, not just your business, not just your small business, your ISP and one organization in your environment, but your entire national economy. And I want to change, that's why I say I want to change the way you think about peering. I don't want you to think about peering being this difficult technical thing. So let's pay the bills. I work for the internet, as I always say. I try to do good on the internet. I try to help make the internet better in one of various ways. And I'm fortunate that the organization that pays me is PCH, Packet Clearing House. We, PCH, operate in 4 different ways. We help with the global DNS Anycast. We help to set up and grow internet exchange points around the world. We help with cybersecurity coordination, and we help with internet governance coordination. We're not going to talk about the last 2 here. We have staff all over. I think I've mentioned I work out of Johannesburg, and my colleague Sarah, who's on the call, works out of Khartoum. We're not here to sell you anything. Let me just start with that. We're not after your money. We don't want you to buy we don't have a product to sell to you. Our job is to help at the core layers of the internet, the low stuff that's really, really low down. We don't have end products that we can take to consumers, etc., like that. It's not the kind of business that we are. Speaking of low down, a good place I always like to start with is, what does the internet look like actually? So this is a project that was done by Kaida.org. Kaida is an organization that tries to measure the internet. And Kaida decided that a good picture of the internet was this. So this picture describes the internet and its different layers of interconnection, and also where interconnection is meant to happen. Now, it's not 100% accurate from our perspective, the way you and I would see the internet, but it's supposedly really accurate when it looks at the where and how people interconnect. I think it's a cute picture. I think, my hat off to the researchers that have done it. I think that there are some inaccuracies. I'm in South Africa. It shows Pretoria. There's very little interconnection in Pretoria, for example. So I like to abstract problems. I like to make my own pictures and to explain the internet in different ways. And this is what I'm going to do for you here. I'm going to show you the internet as a series of 3 different levels. That's the level on the top with the green lines interconnecting and inscribed in a yellow circle or yellow oval. Then there's a middle layer. I call that the tier 2 layer. That's inscribed in a turquoise layer. And I suppose the bottom of the internet is just the internet that's inscribed with the red circle. And if we start at the bottom, we can think about the red circle, red oval inscribed internet as all of the different internet service providers that operate in local context. So this is an internet service provider that might work in your country or he might only have businesses in one city in your country, businesses in one city in a neighboring country next door, etc. It's small, very regional internet exchange points that service the community. Essentially, what these networks do is that they connect us, you and I, the end users of the internet, to the internet, right? And they play a really, really important role because they are what we call they are eyeball aggregators. Eyeballs, people like you and I, they aggregate us. We all connect to these internet service providers, and then, of course, we move up the chain into the internet. A term that we would sometimes use to describe them is third tier. That is not a derogatory term. It's not a bad thing in any sense. It's just where they sit in the level of the internet hierarchy. A level above them are second tier or regional internet exchange points. And a regional internet exchange point will be regional internet service provider will be a service provider that operates in more than one region, perhaps more than one region in your country, perhaps in more than one country. So thinking about Africa, for example, a good example of a regional internet service provider would be, I guess, Seacom or Liquid Telecom. I guess these are names that you can resonate with, right? You would have heard these names like Seacom or Liquid Telecom before because they operate across multiple countries. They operate in multiple different regions. And what they do is they may not necessarily sell to the end user. They may or may not. It's up to them entirely and their businesses. But what they do is the important part is that they aggregate lots of smaller networks that are under them, right? And then there's the very contentious first tier or a global ISP. And the thing about a global ISP or a first tier ISP is that these are the biggest of the biggest networks in the world. They generally only ever connect, well, they sell transit, and I'll explain that in a second, to networks that are smaller than them, but they only ever connect to other internet service providers that are of the equal size. So there's about 13 of these, last I checked, right? They're the biggest of the biggest. So there are people like NTT, there are people like AT&T, there are people like Telia, there are people like who's Cogent. You might have heard of the name Cogent. Everybody sort of wants to become this big first tier network, but it's actually really difficult to do that because to be classified as a first tier or global service provider, it means that you are never ever buying transit from another one. Right? Every network that you're able to connect to is via those green interconnections that you're making to other networks. There's nothing good about being a first tier network service provider. It just means that you're a large network and you connect, you have sites and you have POPs that go across the globe. That's it. It's a marketing thing more than anything else. But the important technical thing about it is that the only way they get access to the internet are via those green interconnections to all of the other networks. And I'll explain more about that as we talk about how networks interconnect. Now, in my very simple diagram, think about the blue lines as lines that connect small networks all the way up into the big networks, right? And those blue lines are what we would call internet transit. It's when you go to your ISP and you pay them money, right? I'll explain transit a little bit more in a second. Think about the green lines as interconnections as no cost. So I'm not paying for a connection to that internet service provider. You'll see why this matters now. As I said, transit, money that goes across those blue lines only flows in one way. If you're a network provider, think about it for a second. When you got connected to the internet, you went to some bigger service provider, probably inside your country or probably outside your country. You cut a deal with them and you said, hey guys, I want 100 megabits a second of IP transit, or I want a gigabit of IP transit. And for getting that 1 gigabit or 100 megabits of IP transit, you paid them money. And the money only went in one direction. The money went from your pockets to them. They didn't come to you to say, hey, can we sell you transit? And by the way, for collecting all of the users like you are doing, we're going to pay you money. That was not a reciprocal relationship. The money flows in only one direction. And I know what you're going to say. You're going to say, there's this Indian guy here and he's talking about money. This is what happens all over the world. Don't worry. I'm not trying to take your money. I'm trying to get you to understand how your money works. You are always paying for transit. I think this is a very important picture because that line, the interconnection, the map of the internet as I drew it loosely, the line that shows transit, if it wasn't clear to you about how the economics of the internet work, this is how the economics of the internet work. You are always paying for transit. We are always paying for transit. Us in Africa, we've always paying for transit. We don't have big tier 1 operators or anything like that. We're always connecting to the global north, as they say. But somewhere in this place, the second tier networks, and there's a long and fascinating story of how interconnection started in the United States in 1994. The second tier networks realized that instead of just paying money upstream, sending money up the chain all the time, what they could do was they could start interconnecting amongst themselves. And if we interconnected amongst ourselves at that second tier level, we would still have to go to the big networks, the global tier 1s, because there's some networks that we don't have access to, that they have access to, that we would want to get to. But we don't have to send all of our traffic to them. And if we don't send all of our traffic to them, then what happens is this very important thing on the left-hand side. We still buy transit, but the amount of transit that we buy has now reduced. See, that fat line has become a lot thinner. So we spend less money on transit and we have more money that we can keep inside our network. When this sort of, hey, we can interconnect with each other thinking started to take hold inside the mind of the second tier networks, it also became a thing inside the smaller networks as well, right? Small regional networks inside countries decided that they could interconnect with each other. And that place where they chose to interconnect, that place today has a very special term in internet world. In the internet world, we call that an internet exchange point. So today, an internet exchange point is a meeting place for networks to interconnect with each other. And the first thing you're learning is that an internet exchange point is going to help you to save money on your transit. You're going to send less. You're still going to need transit, of course. You still need to send a packet to someone who's not at the internet exchange point, but it's going to save you money in the long term. You're not going to spend as much money on transit. Hopefully, the second thing you've learned is that exchange points are open to everybody, and we'll talk a little more about who can connect and how they can connect a little later on. Now, I've been using these terms a lot, and I promised that I'd explain them. So here's the terms for peering. Here's a definition, rather, for peering in transit. You don't need to take screenshots or try to write all of this down. I'm sure that the BINOG team will make sure that these slides are available to you later, so you can, pay attention to what I'm saying instead. So what transit is a commercial agreement. Let's stop right there, right? Transit is a commercial agreement. You go to some bigger network, you sign a contract, and that contract is for money. It is a commercial agreement. That's the important thing. It's a commercial agreement and it's underwritten by some measure of cash, some measure of service, or some measure of a utility that they're going to provide to you, the transit, and the compensation for that. So always, just it's difficult, I think, to confuse transit if you think of transit as a paid for service. It is a paid for service. It's, I don't want to do the work. I am paying you, take my money, and just give me the internet. When you first got connected to the internet, in fact, when all of us first got connected to the internet, this is how we connected to the internet. I ran an ISP in 1997, and even in 1997, before that, the way that the ISP was connected to the internet was to get some line to the internet via some external provider, and then, communicate. But as the internet started to grow, you saw we just walked through a very simple growth pattern. We started to make those interconnects with each other. And those interconnects with each other are what we call peering agreements. Now, agreements is a loose term because largely what most of those network operators say is that we want to change traffic with you. We will change traffic with you generally at an internet exchange point. We won't charge you for sending you the traffic. You don't charge us for sending us your traffic. So these $0 arrangements, $0 as in it's free, there's no money to do this. These $0 arrangements are largely underlined by handshake agreements. I'm using a lot of terms, I'm using technology, I'm using terms that might not be common to you, like handshake agreements, because once you start doing this, once you start working in the peering world, you'll hear these things. So what is a handshake agreement? A handshake agreement is simply an agreement with the a loose, informal agreement with the network that you want to peer with. It's as simple as two people shaking hands to say, let's do this. Now, at PCH, we run a large peering survey. It's the largest peering survey in the world. We do it every 5 years. We started in 2011. We analyzed a few 100,000 peering agreements. We did it in 2016. We analyzed like 6,000 peering agreements, 6 million peering agreements, I think. And we've just done it in 2021, I think it was 2021, where we analyzed something like 19 million peering agreements from across the world. So for example, Afrinic is on this call. Afrinic peers at the Johannesburg Internet Exchange Point. Afrinic has also peers with a whole bunch of other networks there. Afrinic would have been one of the networks that responded to us. And we asked the networks a few questions, and I'm not going to go through them here. Sarah will put a link to the peering survey in the notes for those of you that are interested. But one of the questions we asked, and this is a really important question, is do you require a formal peering agreement to peer? Or are you happy with the handshake agreement? From 19 million peering agreements across the world, 99.998% of the network said that they do not require a written formal contract, and that handshake peering was good enough for them to get peered. That is fantastic. And I can tell you that from the 3 years we've done that survey, that number has always gone up. So the first part about peering, where you may be worried to say, oh, I don't know if peering is going to work, it's difficult, it's people have to have contracts. And I'm going to tell you this, as Africans, we make it difficult for ourselves. Cedric and I are doing work now in a country in what is this, West Africa, where every time they want to send a reply in email to us, it's almost like they want to go and get a government stamp and send us a reply instead of just sending mail. They create these inefficiencies. And I'm telling you that we create these inefficiencies because I have the data that tells you that for the rest of the world, 99.998% of the networks, they don't care. They just want to peer because they can see the value in peering. So if you're on this call and you think it's difficult to get peers at an internet exchange point, you think it should be difficult to get peers, you think you can't get peers, then please go and read the survey that Sarah has posted into the chat and write to us and tell us why you think that's the case. And trust me when I tell you, we have the data to show you it doesn't need to be difficult. Peering agreements, super simple, super easy. No contracts required. You don't need a contract for a peering agreement. And peering agreements are free as opposed to transit agreements. So I'm going to stop for a bit because I can't see your faces. I can just see I can see names on a black screen here. I want to make sure you are all awake. And I want to know if you have any questions before we move on to the next part of this. Questions?
Yeah,
Tell me if there's something you disagree with.
It's fine. That's very nice up to now.
All right, I must apologize. I don't speak French. I know that French is the governing language in Burundi, but I only know about 10 words. So
I believe it should be fine because most of the engineers usually have a kind of knowledge in English due to the fact that we usually use the equipment and documentation which is written in English as well. So it should be fine at the moment.
All right. If I'm speaking too fast, if there's something that's not clear, please stop me. Tell me, hey, we don't understand. If you don't want to tell me, you can write to Olympe or Cedric, who are coordinating this call, and you can say, tell him he's doing something stupid. I do stupid things all the time, so it won't shock me. Last chance. Are there more questions so far? All right, let's move on. So let's talk about what happens when. Sorry. Let me share something with you. For those of you that are not internet service providers, this is the internet service provider's dirty secret. For those of you that are internet service providers, it was a secret a long time ago. Yes, I agree. It is no longer a secret because I've been telling the world about this. So if you're trying to shoot me, this is a Zoom call. You can't do damage. As an internet service provider, because this is who and this is where and how our traffic connects to the internet. Internet service providers only have 3 ways. Only 3 ways to move traffic across their network. Now remember, you are paying your ISP, and it is the job of your ISP to take the packet that you paid them for and to deliver that packet to wherever it needs to go. And they're not doing this as a favor to you. You are paying them for this service. There are only 3 ways that your ISP can move packet. And I want you to understand this if you're a non-service provider, because you must take this information and maybe teach your ISP if they don't know it. And I want you to understand this if you're a service provider, because this is really, really obvious. And this should define how you think about designing your network. This is not the BGP code to run your network, but this is the backend intelligence you want to use to develop the BGP code, which we can do in a different Zoom call if you'd like, to run your network. So let's get to it. In scenario number 1, we've got this ISP in the middle. It's this green ISP. It's a neutral service provider. And in scenario number 1, we've got this ISP that has 2 customers, customer on the left, customer on the right. We call them green customer and green customer 2. And they want to send messages to each other. They want to communicate with each other. How would traffic in that case work? Well, I'm looking at the left of my screen, so you can look at the left of yours. The packet is with the green customer. The packet would go all the way from the green customer into the green network. And along with that packet, the green customer is paying the green network $1, $1 franc, right? On the right-hand side, you've got the green customer, and the same thing's happening. That green customer is paying the green network $1 franc. When the packet enters on the left-hand side, it goes through the green network. The network, through its technical workings, routing protocols, what have you, determines that the packet needs to go to the right customer. It goes through the green network and it gets delivered to the green customer on the right-hand side. Now, in the course of that entire process, the packet came into the green network. It stayed inside the green network. It didn't go out, and it went to the customer on the other side. So our ISP has earned $1 franc and $1 franc. And the math here is not difficult. We're working in base 10. So this is 2 francs, right? Our network has earned 2 francs. Our network obviously needs infrastructure. We're not going to talk about the cost of that infrastructure. But more importantly, our network didn't need to pay anybody to deliver that packet because the customer was my customer. They were on my network. We have a term for that in the industry. We call that on-net traffic. It's on my network. So I don't need to pay anybody. I can deliver. And at the end of the day, I can say I've earned 2 units, 2 francs. Yay, I've done well. Fantastic. Now, that's great. But this is not an accurate representation of the internet. The internet, of course, is not just one network. The internet today is almost 80,000 different networks that are spread all across the world. And because we're talking about Burundi, Nog, we know for certain that not all 80,000 of those networks are in Burundi. If you want to talk to me, for example, my network service provider is in South Africa. The Mauritian network service provider, the Afrinic service provider is in Mauritius. So from Burundi, there's got to be a bridge to get to Joburg and another bridge to get to Mauritius. How does that work? Well, to do that, we have the magic of the transit network. So let's go through our situation again. Let's assume that you're trying to send a packet to the Afrinic office that's in Mauritius. The green customer sends traffic to the green network, and the green network collects money for it. But the green network cannot communicate all the way to the rest of the world. He has to go through a transit network in the middle, some big network, we don't know who, and that big network charges the green network money. So you earn a franc and you spend whatever you spend, we don't care, we'll call it X, right? On the other side, you've got the red network, who's got the red customer, say Afrinic in this case, and that red network is also, because Mauritius is an island, they don't have a lot of service providers, that red network also connects to a transit provider. And in the same way, that red network is collecting money from Afrinic, that 1 franc that we discussed. The red network earns the franc, but that red network has to pay to a transit provider. At the end of the day, the green and the red networks, the service provider networks, have earned the value of the money that the customer paid them, 1 franc, minus whatever they paid to their transit providers, 1 minus X. So the immediate thing here is you see that when you introduce a transit provider into the situation, you are always earning less. This is what I want you to see from this slide, right? It might seem like a slide that you would show to maybe like a grade 3 student. So I apologize if it looks very simple, but the concept here is also very simple. When you send packets to a transit network, you lose money. Scenario number 2, right? Scenario number 1, you keep everything. Scenario number 2, you earn some money and you pay to a transit provider. Let's go to the third scenario. The third scenario is you have the 2 networks, the green and the red networks, but those networks are directly connected, say they're connected to the same internet exchange point. Now, when you get connected to an exchange, when you connect your customer, you have to invest in infrastructure. You have to have fiber in the ground, you have to have 5G. We know we're not talking about those infrastructural costs. What we're talking about here are simply costs to connect to other networks, costs to exchange traffic. This is important. This is the important distinction. In our scenario here, we have both networks connected to a local internet exchange point. The green, as usual, the green customer sends his packet into the green network. The green network earns 1 unit. So we're making money. We got our 1 unit again. But because I'm sending money across an internet exchange point, I'm not actually paying the network on the other side for taking my traffic. Because when I connected to the exchange, I wrote to everybody to say, hello, I'm the green network. We're from Bujumbura, and we want to peer. Who wants to peer with us? And you got back a lot of these virtual handshakes, a lot of these agreements that said, yes, we'll peer with you, don't worry, and we'll peer with you at no cost. So your cost for sending money across the IX is 0. And because your cost for sending money across the IX is 0, and by the way, the network on the other side is also paying 0 to get connected to the IX, your earnings at the end of the day are 1. So 3 situations. A situation as a service provider where you earn 2. A situation as a service provider where you earn 1 minus X. And the situation where you earn 1. Where do you want to be? If you were a transit provider, if you were the green network, the green ISP network, which one of those 3 would you want to be? You can either put your hands up, you can shout out, you can type. Cedric is going to help me find out who responds. What makes sense to you? Where do you want to be? None of you want to run an ISP business, or none of you want to make money. Which is it?
We want to make money.
I think that some of them actually are working for ISPs.
Yes. Yeah, we work to yes, sure, work for ISPs.
So come, guys, which situation do you think is the best to be?
The third one, and maybe a little bit of transit, because at some point you always need some part of the network that is part of your IXP. So in
Okay, that's a good answer.
Yes.
That's a good answer. You've never worked for Burundi Telecom. Anybody here from Burundi Telecom? Anybody here from an incumbent? Well, the incumbents will tell you the best place to be is 2, and they're right. They're absolutely right. The best place to be is when you earn 2 units. Absolutely, because that's where you make the most money. But the reality is it's not achievable. You cannot lean to, because no single network is big enough to cover the internet, the planet. And while the incumbent telecoms will tell you it's okay, we can do all of the country, the one thing that is true across the world is that incumbent telecoms have never been able to provide consistent service across an entire country. So 2 is fantastic, but it is also unachievable. So actually, there are only 2 situations that we have where you can earn 1 or where you can earn 1 minus X, right? It's where you are either buying transit only, or you are obviously buying transit and then getting connected to an internet exchange point. And very, very simple arithmetic would tell you that if you're a smart internet service provider, the thing that you want to do is you want to maximize your peering. Because if you can maximize your peering, what are you doing? You're spending less money on transit. Right. This is, if you can snapshot this into your brain, the slide, I would love for you to do this. Because when you understand this, again, this isn't the BGP that's going to drive your network. But when you understand something like this, maximize my peering, then when you go and sit down and you write your BGP policy, then you will understand why you need tools like local preference, which is an important construct in BGP, and why local preference needs to be higher at your internet exchange point and lower at your transit providers. So please screenshot this into your brain. And don't think that because we're not using technical terms in this talk, the things that we're trying to teach you don't apply to the technology that you apply to your network. The conf T and whatever you are typing in your routers must come from sound economic policy. And this is the sound economic policy around peering that you should always remember. And even if you're going to tell me we don't have an exchange in my city, or the exchange isn't working, that doesn't matter. These are still the principles you will use if you build a network that spans 17 countries. That was the size of the network I ran when I stopped being a network operator. We still used exactly these rules. Okay, I'm going to pause to see if there are more questions. Anything that's not clear or you'd like me to repeat somehow? Questions? Anything?
Yeah, I do have a question.
Sure.
Yeah,
Go ahead.
you meant that's for the case of Burundi, where data that we usually access beyond our borders. So can peering really help the ISPs to save so much money when we don't have yet so many content hosted locally? Or what shall we do actually to maximize?
That is a fantastic question. That's probably going to be one of the best questions that we get asked today. So there's a lot to unpack there. The first is peering in Burundi is really small right now. Does it really make such a big difference for us? And can we save this much money? So the answer to can we save this much money is one that only you can answer. Because you, as network operators in Burundi, you know what it costs you to pay a transit provider. Okay. So let's be mean. I don't like PCCW. Let's use PCCW. PCCW is a network you should never buy transit from, by the way, for a whole lot of reasons. Let's say PCCW comes to your country and they say, we want to sell you transit, and the transit is $10 a megabit. Okay. What you need to do is you need to say, well, I'm going to send some of my traffic to PCCW. Of course, I live in Johannesburg. If you were going to try to send a packet to me, the networks from Johannesburg are not at the Burundi Internet Exchange Point. The networks from Burundi are not at the Johannesburg Internet Exchange Point. So there still needs to be a transit provider in the middle, okay? And that might be anybody. So you know that PCCW is offering this to you at $10 a megabit. The alternative is to see, where can I go to as a network operator? What would it cost me to build to say Kigali? Because Kigali is not far and they have a working exchange. What would it cost me to build to Kigali? I have to get to Kigali. I have to pay transport. I have to lease fiber from somebody. When I get to Kigali, there may be a port or may not be a port fee at the internet exchange point. But what is the per megabit port cost for me to get from my network from here to Kigali? And then can I get access to the networks that will allow me to get directly connected to Nishal in Johannesburg? Now, one of my transit providers is Liquid Telecom. Liquid Telecom peers at the Kigali exchange point. So if you could get to Kigali, you could probably peer with Liquid. And guess what? Your packets to me would become free. Free because the cost of getting it into the Liquid network is zero. You still paid for transmission, of course. You had to lease fiber all the way to Kigali. And is that more or less than $10? If it's less than $10, this is probably a win for you. And this is probably something you want to do. Okay. The second part of it, how do we get them into Kigali? How do we get them into Burundi? We'll address at the end of the call because there's questions I have for you guys. Okay. There was another hand, Lambert. Did you disappear, or did I answer your question? Or
You
did
wrote
drop
it.
off?
You wrote it. You wrote it in the chat.
You wrote it in the chat. This is going to test my multitasking ability, guys. I'm a man. I'm not supposed to know how to multitask.
That's a myth.
Oh, right. Can you explain the difference between green ISP network and red ISP network? Lambert, in our example, the green ISP and the red ISPs were exactly the same. They're just networks that sell services to their subscribers. There's nothing different about them. I just needed to show you how packets would move between the two networks. And I think in the next part of my presentation, you'll probably see and understand that better, okay? Sarah, when you say maximize your peering, you mean peer in different locations? Yes, I mean peer in different locations because peering in different locations is a good thing, as I'm going to show you in the next set of slides. Okay, so let's move on. So we know now that we should start peering. Where should we start peering? Well, before I tell you the how and why, here's a list from the PCH IXP directory. The URL is at the bottom. You can go and visit it yourself. Sorry, I'm clicking in the wrong places. There are about 750 odd active internet exchange points in the world. And yes, if I can scroll into this map, if I could scroll into the map on a presentation, you will see that there is an internet exchange in Burundi. We list it in the PCH IXP directory. It's active, although there's lots of things that I think that you could do to make it better. And I think that those things are going to come out of you as a community saying, we want the exchange to run better. This is how we can run better. This is the help we need to get it to run better. And this is why we are doing it. And hopefully the why will be answered at the end of this. Look at the map carefully, or even don't look so carefully, and you'll see something that's really astounding. Every yellow dot is an internet exchange point. In Africa, there are 6, soon to be 7 internet exchange points in South Africa. So if your geography is bad, we're all the way at the bottom of Africa, right? That's South Africa. We've got 6 IXPs, and they're run by 2 different organizations. Tanzania has 4 or 5 internet exchange points, depending on the day of the week and whether or not the exchanges are up and running. And that's it. There are very few other countries in Africa that have multiple internet exchange points. The DRC, because it's huge, so you can't have one exchange that fits everybody. So DRC has 3. Nigeria has two working exchanges. No, I lie. Sorry, Nigeria has three working internet exchanges, but most of the other countries don't. And even worse, some countries in Africa, the whites, don't even have internet exchange points yet. So our goal should be to fill in that map. Our goal should be to have, not as the politicians say, an internet exchange in every country, but as we say instead, we should have an internet exchange in at least every large city, because internet exchanges serve people. And we're hoping that in a few years' time, that map of Africa will finally be full. And if you think I'm overstating the case, think about this simple fact. How many times have you heard people tell you that Europe is really, really, really tiny and Africa is really, really, really large? We know that to be true already, right? We know that the map representation of landmass. Why are there so many internet exchanges? Look at Western Europe. That we consider Western Europe developed, right? Developed countries. Why are there so many internet exchanges in developed countries? Look at the United States. That country has more internet exchanges than anyone else in the world. And why are there so few in Africa? There are more exchange points in one country, the United States, than there are in all of Africa. So we need to get more exchanges if we hope to build development in our region. If you are here on this call and you are here because you want to learn, and you're here because you care about Africa, you care about the future of your country, or even if you don't care about all of that, if you care about making money for yourself, as Olympe said, you care about making money, which is important, you have to realize that making money for you, even for a selfish reason, making money is related to development. So how do we get development happening? And how do we get more yellow dots in our region? That's a question we will discuss at the end. Let's move on quickly. So very quickly, why do we peer? You've already heard me explain the part about cost reduction, and that's only the start. I could speak the whole day on how you can save cost. There's performance. I think that makes sense to you. If you are peering and you are connecting with somebody that is in your location, performance is much better. I don't have details about performance here because, again, I think that performance is an easy thing to understand. Tool, we're explaining that, and I'll continue now. It's a tool for national security. If you have never heard of Edward Snowden, I suggest you go read about Edward Snowden now, and he will give you fantastic information on how some of the more developed countries do data analysis on our data. We shouldn't be allowing that. You should keep your stuff in country. There's no reason a minister in your country should have a yahoo.com email address. That's wrong, wrong. And the only reason that they say they do it is because they say the services that the locals are providing in Africa isn't stable. Well, why? Are you people idiots? I'm not an idiot. I mean, I do stupid things, but I'm not an idiot. Are you idiots? I don't know most of you. I can't see your faces. I see little black boxes. But I want to believe that you're not. I do. I want to believe that you want to make a difference and you want things to be better, and you're here on this call, and hopefully you'll be on the next series of BINOG calls because you want to make the community in Burundi better. If for no reason, because you want to earn more money, right? And then you can't be an idiot. If you're looking to the future, you can't be an idiot. So if you're not an idiot, what's stopping us from developing these tools? Well, in my mind, only one thing, and that's experience. And we can fix that. We can fix that experience by building, by growing, and by learning from our mistakes. And that's what we hope to, well, help you share in the future. Because if we can do all of these things, then we can do that one magical thing that our politicians love to talk about, and that is to build our knowledge economy, which is a fancy way of saying make people in our environments smarter, so that they can make more money out of doing smarter things, which ties with making more money for you, which is why we agreed you're all on this call, right? So let's see if we can get to this, and let's see what it takes for us to get to this. I'm going to talk a little bit about the internet lifecycle, the way an internet service provider, or the way that an economy starts seeing this. But before we do that, and you can do this by just doing the show hands, raise your hand thing, which I am told is somewhere inside reactions. I don't know. You can figure it out. Firstly, how many of you run a cloud business in your country, or you have a business that runs a cloud business? And if you don't run a cloud business in your country, offering virtual private services, virtual VPSs or VMs or something, how many of you want to do this? Anybody see this as a business opportunity in Burundi? You can just do the raise hand thing on Zoom and tell me if it's interesting to you or not. One person is thinking ahead. I can't see anybody else. All right. So for the one person, I'm going to ask you, if you think you're going to run it today, what would you charge for a VPS? Would it be $100? No, that's too much, right? You can't charge $100 a month for a VPS service. Would it be $10, $10 US? What do you think?
Maybe 50.
Does that sound fair?
Starting point, maybe for people to get used to it.
All right. Would it be $1?
Yeah. That would be too low.
Why? Why would it be too low?
Maybe because of the technology, the infrastructure, the support, everything, the power.
Your costs.
The cooling. Yeah, to operate.
Right? Your costs. You're right, by the way. Charging $1 for a VM or a VPS service in Africa today means that you're going to run out of business very short, very quickly. You might have a lot of funding, a lot of investors, and then you won't have any investors because they'll see that your product is not viable. Could you do it for $2 or $3? At this point, I still don't think so. But I can guarantee you one thing, that if you go to buy a VPS service in Amsterdam or Frankfurt, you could get it for $2 or $3. And if you think I'm lying, I'm going to send Cedric on a mission. While the rest of this talk is going on, Cedric has heard this talk many times. Cedric is going to find out what the cost of a VPS service is in Amsterdam and Frankfurt. I hope your German is up to scratch, Cedric. I'm telling you that I'd love for you to do this. I would love for you to introduce these types of services in Burundi because, frankly, today there are really no cloud services. Amazon, the big guys, they don't have services in Burundi. And if you're trying to get to their services, you're sending it to either Kenya or you're sending it to South Africa. And when you are sending it out of your country, it's costing you money. So you can understand why I'm telling you I would love for you to start these services. But at the same time, I'm telling you, you can't do these services for $2 to $3. And let's start to understand why. Does this look familiar to you? This is accurate as at last night, about 21:30 South African time, 9 in the evening. This is what the Burundi franc looks like against the US dollar for the past 10 years. Over the past 10 years, your currency has lost 24.53% of its yield. So compared to 10 years ago, if we didn't have if we discount inflation, if you had 100 francs, you could buy 25% less things than you could today. Very simple explanation. Oh, you guys live in Burundi. You know what 100 francs would have gotten you. Sorry, I shouldn't say 100. The conversion rate when I looked at it last night was $1 is now 2,000 francs. And all of you here are hopefully more than 10 years old. If you are not more than 10 years old, if you're under 10, I hope you have your parents' approval to be on this webinar. That was a joke, but anyway. You remember what $1 cost 10 years ago. I don't have to tell you, okay? By the way, before you start saying, oh, Burundi, we love you, we hate you, what is going on with our country? Let me show you something else. This is South Africa. And if you thought 24% was bad, look at our currency. It's 48%. So if you are crying, believe me, I'm crying too. Okay? I could do the same for Senegal. I could do the same for Mauritius. I could do the same for Khartoum. And Sarah is laughing on this call because, guys, trust me, you don't know how the Sudanese currency has fallen over the past 10 years. One thing is clear from all of these examples. We live in lands where our currency depreciates all the time against a foreign reserve. So if our goal is to start to live and buy in US dollars, and whether we like it or not, that is our goal. If we're a service provider, we're living and buying in US dollars or euros or yuan, perhaps in the future. The point is simple. Our currency is failing against external currencies. And so we can't continue to use external currencies to continue to grow our business. Of course, we can't remove external currencies. We have to buy routers and switches, perhaps in US dollars. We have to buy transit, perhaps in US dollars. But what should be clear to you is that because our currencies are volatile and because our currencies are continuously dropping, we have to reduce our reliance on those currencies. This is what I want you to see. Yes, this is what you get when you ask an economist to do a talk. I always talk about things like foreign exchange, not BGP. Why is this important? Well, let's see. Here's what the networks looked like when there was no internet exchange point in the country. You had a single transit provider. That single transit provider collects money from your customers. So I go down to my customers in my country. I collect money from them. And I collect the money in francs because this is how they pay me. None of my customers are paying me in US dollars. All my customers are paying me in francs. I collect all the money in francs. I then take that money. I provision everything that I need to provision in the service, in my network for services. And then I go to my transit provider and I buy transit. In this example, you might think that you are an internet service provider. I'm going to tell you that you are not. You're not an internet service provider. What you are is a foreign exchange dealer because you're not doing anything. You're connecting, you're taking a packet from your customer, you're plugging it into your network, you're running this network, and then you're sending that packet outside. You are taking francs in your local economy coming in from your customers. You're using a little bit of it in your network to pay for your bandwidth, pay for your staff, and then you are buying transit in US dollars. You're a foreign exchange provider. Worse, when you sign a deal with your customer, you can usually sign a deal for 1 year because that's generally how long your customers are wanting to sign. But when you buy a deal from your transit provider, when you sign a contract with them, it's not for 1 year. It's actually usually about 3 years. And if you think you are winning, I'm going to go back 2 slides and show you the reality. You're not winning. Because if over those 3 years, your currency is depreciating and you're paying more for transit, even though you're thinking I'm still paying the same every month, it's still $1,000 for a gigabit, you're paying more. I am not telling you are paying more. xe.com, historical currency exchange rates chart from there is telling you are paying more. So this model is fine because this is how we start. Right? Everybody started as being an internet service provider that provided very, very simple transit. That's perfectly okay. But this model for us is not sustainable. You cannot continue to run the internet in your country in this way. Now, if you were in one of the very few countries in the world where there's only one internet service provider, you don't have a choice. But you guys are not Greenland. You're not Eritrea. You have competition. So you can do better. What is the better? Well, here's one view of what the better is. You can run things the way you were, and then you can get 2 transit providers. And usually you do this because you think you're buying redundancy. If my first transit provider goes down, I still have access to the internet. And that's true. That's 100% true. You're getting redundancy in this situation. What you don't realize you're doing is as an internet service provider, you are also doing least cost routing, LCR. It's happening under the scenes. You didn't ask for it. It's still there. Here's how it works. When you had one internet service provider, you are the white network, you connected to a transit provider, one transit provider, the red network in this case. Let's say you were trying to get to 2 destinations on the internet, destination A and destination B. And the number of hops between your transit network and destinations A and B were 5 and 7, as I've drawn in the diagram. Now, because you have one transit provider, you don't have a choice. You send your packets along those paths. And for us, if these were the busiest parts in your network, for us, we can compute that the average length between your customers and your destinations on the internet is 5 plus 7, 12 divided by, well, we're talking about two different networks here. 12 divided by 2 is 6. So the average length for you to get connected is 6. When you introduced a second network, when we added a second network provider for resiliency, because the second network provider might use different transit operators, and you should check that before you buy transit from a second network operator. The path to get to those networks, A and B, is now different. And whether you realize it or not, that magic thing called BGP in your router is going to start to figure out the best paths for you to get connected to those same networks A and B. In this case, the best path for us to get to network A is going to be via red. The best path for us to get to network B, our new transit provider, is via the green network. And so you can see this is what happens. The average length for our consumers to get to the internet is now 4. Congratulations, you've made the internet better for your users and for networks A and B, who now have to go through a shorter path to get to you. You've done this automatically, simply by adding an intelligent network, second network service provider that is using different transit. And more importantly, without you doing anything, your network has automatically reacted. BGP, shortest path, average length is now 4. This is a good thing for you to do. So adding a second internet service provider, I'm willing to bet most of you don't think about it this way, but it does do this least cost routing that we're showing you here. And that's fantastic. But the problem here is that you are still pushing money out of your economy. What can we do to not send money out of our economy? And that's where a single internet exchange point happens. That's where we start building the first exchange in our economy, and we start to send more and more, and we start to recognize that we can peer traffic to the internet exchange. And if you've listened to me by now, you should know that you want to maximize your peering. Every packet that is potentially available to be sent across the exchange must go across the internet exchange point. And of course, when you start, the exchange point is going to be very small because there might not be a lot of users, there might not be a lot of content in your country. But any smart engineer will start to understand that even if it's small today, it's not necessarily going to be small in the future. If I can build, if I can grow, if I can send more stuff across the domestic internet exchange point, the traffic to the exchange point will increase. Because the exchange point is one hop away, the networks at the IX are one hop away from me, what's also going to happen is your network is also going to choose those paths. Because you just saw it, the least cost routing example that I showed you. If you introduce a shorter path to your network, your network will automatically choose this. And that is a good thing. So, listen, get connected to the IX, get as many networks as possible connected to the IX, and send whatever you can to the IX because it saves you money, makes it faster, and does a whole lot of other good things that we've spoken about and more that we will still speak about later. There's one point I want to stress here, and that is get as many networks connected to the IX as possible. The service providers think that internet exchange points are for them. In my slides, you'll see ISP networks everywhere because most of you here are ISPs. But there's no reason that a bank shouldn't be connected to an internet exchange point because banks run services that your users want. I mean, I guess everybody here has some kind of domestic digital banking service, and you want that to be a highly available service. There is no reason that universities shouldn't be connected to the internet exchange points, particularly now when we have things like COVID and students are sometimes working from home, universities sometimes get closed. I don't know what the story is with you, but I know in South Africa, universities have been closed for a long, long time, and students were all working online. And the only way they could sustain working online was if the universities and the mobile networks and the fiber networks were all together in one location at the internet exchange point. Because getting them together at the exchange point means that it is cheaper and faster to get students online, to get lecturers online, and so universities can continue. So who should be at the IX? Anybody. Anybody that has an IX, an autonomous system number, anybody that can go to Afrinic and get their own resources, and anybody that is willing and able to configure BGP. Okay, the last part of this is what the eventual outcome of your economy will look like. You will start moving from ISPs. Look at our middle cloud. Our middle cloud is now internet service provider networks. But in the last step of this, we've migrated to network service providers. Network service providers are networks that carry other networks. This is when the networks in Burundi become so big that other networks from outside your country start to say, hey, we want to go from A to B. Can you, Viettel, Burunditel, all the different ISPs, can you provide us with a least service end to end and not put your IP addresses in the way? It's when the big networks in your country start to understand that they can start running wholesale businesses and selling retail down to only the ISPs, right? It's when the big networks, small networks, start to understand that they can provide service only in a small region, maybe in 1 or 2 different suburbs, and still start to use resources like at the Internet Exchange Point. And hopefully in the future, it's where you have multiple Internet Exchange Points within your country. We won't go into that yet. I have to look at the geography and population spread out before I can make an intelligent answer about that. But this, for example, is what the internet looks like here in South Africa today. We have lots of service providers. We have over 300 that provide services in for lots of various different ways. We have multiple exchange points, 3 cities. The 4th city per se will now get its own internet exchange point in May or June, and we think a few more will come. This is where I want to see your future go. We have an understanding of what we're doing, but let's talk about how packets move, and this will help answer the question that was asked before about maximizing your peering. How do packets move during this during an internet transaction? So here we've got a green customer, or rather a red customer on my left that wants to speak to a green customer on my right. We've got red network and the green network, and this is just any network. There's nothing special about them. The networks themselves have transit, as in if you want to get to the rest of the world, but the networks each connect to an internet exchange point, IXP1 and IXP2. In the case of IXP1, this is very close to the red network. IXP2 is very close to the green network. And both our internet service providers, ISPs 1 and 2, are connected to each of these internet exchange points. Now remember one thing, that when you connect to an exchange and you agree to peer, like the red and the network have already agreed to peer, you're shaking hands. You're shaking hands to say, I'm willing to peer with you. And if I'm willing to peer with you, it means that packets that I send into your network, you should deliver to the best of your ability. That agreement has already been made. So the red customer wants to send a packet. Let's say they're sending an email message to somebody inside the green network. What happens? Well, the red customer sends the packet to the red network. It gets inside the red network. The packet's inside the red network, and the red network now needs to understand, I have this packet, it's going to the green network, what do I do with it? Now, the red network knows that it can connect to the green network in one of 2 ways. It can send it via the short link to IX1 or the long link to IX2. What does it do? You and I are human, right? We have intuition. We have human intuition. And the human intuition here says, probably send it to IX1 because IX1 is closer. And that's fantastic. But that's not the thinking that the red network does. The red network makes an economic decision. It says, I've got this packet in my network. I need to figure out how to send it. And the primary driver for me to decide where to send this packet is going to be, what is the cheapest way for me to send this packet? The cheapest way for the red network to get rid of the packet is probably if it sends it to IX1. So that's exactly what it does. The red network makes an economic, nothing else. It makes an economic decision to say, send the packet from my network all the way into IX1. Now, an IX is just a switch, right? It's a fancy way of saying it's inside the internet exchange and it's now, well, connected to the green network. What do I do with it? Well, the green network has the packet. The green network has already signed this agreement, handshake agreement with the red network that says, if I get your packets for my customers, I will deliver them. The green network knows that this packet is meant for the green customer. So it backhauls the packet the long distance, right, inside its network. And once it's inside its network, it delivers the packet to the green customer. Delivery achieved. But you know, as engineers, that this is not the complete picture, because our internet, the internet model that we know, is made of send and receive. So now the red customer has got to respond to the green customer. Sorry, the green customer has got to respond to the red customer to say, I've got your packet. Either stop sending it to me or send me more. One of two things. And the green customer now responds. The green customer sends a packet to the green network operator. The green network operator is paid by the green customer to deliver this packet. But now he's got to make the same decision that the red network made a short while ago. Where do I send the return packet? Do I send it to the exchange that is closest to me or the exchange that is furthest away from me? And because we want to believe that network engineers are rational people, the green network will send the packet to the internet exchange that is closest to it to do one thing and only one thing, and that is to minimize cost. When the packet is at the exchange, the red network goes, oh, you've got a packet for me. It's now my turn. It's the turn of the red network to backhaul that packet the long distance all the way into the red network's network and then deliver it to the red customer. And that is an internet transaction. And every single day, this, what you've seen on the screen, happens trillions of times a second. This is how the internet works. In a model like this, the red network is responsible for its own costs, and the red network has costs. The red network has to build its network. It has to connect to its customers. So it has to have 3G, 4G, 5G to get connected to customers. It's got to have LTE. It's got to have whatever customer-facing technology. The red network has to get connected to the internet exchange. It has to lay its own fiber to the IX that is close to it. It has to lay fiber to the IX that is far away from it. It has to pay network engineers, etc., etc. But what happens here is that the red network is carrying its own expenses. It receives money from its customer, and it uses that money to invest in its network and to grow the network. The red network's money is not being used for the green network, because the green network does exactly the same thing. They make their own investments. They pay for their own transport. They pay for their own fiber. They pay for their own 3G, 4G, 5G services for their customer. In the example that I'm showing you, in the model of the internet as we know today, every network is responsible for their own costs. That's important. That's not the way the telco networks work today. The old packets, the old circuit switching networks of old, but this is the way the internet network works today. And the internet network works this way if they use, I should say, the networks, use a technology called hot potato routing. Think about a hot potato. Imagine putting a hot potato in your hand. You can't hold it in your hand for a very long time because it's hot. It's going to burn your hand. So as soon as the hot potato comes into your hand, you're trying to get it out of your hand as quickly as possible. Where is the easiest place that I can put it? Can I put it on the sink? Can I put it into a pot? I want to get rid of it as quickly as possible. That is the idea with routing and packets. When you get a packet, you want to get rid of the packet as quickly as possible. And getting rid of the packet as quickly as possible is why this send the packets closer to exchange point 1 makes sense for each of them. We've explained the fair sharing of costs, so I don't want to spend more time here. And a note here, the efficiency of the internet depends on what I've just shown you, all right? For two parties to share traffic equitably, to share traffic fairly, there must be an exchange near one of them, near each one of them. I'm going to leave this here and allow you to read it and think about it for a second. But my personal perspective on this rule is seeing it from a different angle, the corollary. And that is that if you don't have a working internet exchange point near you, right, you are always going to be exporting capital. So in our example here, if there was no IXP2 near the green network is always going to be on the long distance path of sending fiber. It's always going to be the network that is exporting capital, paying more, let's call it that.
The Germans do it a lot. Let me give them a slide on this.
Thank you. Thank you, Cedric. The green network in the example, if there's no exchange near you, you're always paying more. I asked you earlier on why you can't spend $1 or $2 to run your VPS business. Cedric pasted the answer into the chat. So let's go and see what he found out from his research. Where is his research? How do I scroll to get to his research? I am hopeless with this. Sorry, I really suck at using Zoom. So Cedric says, for $4, you can get a VPS in Amsterdam for 1 gig of RAM, 1 core, 20 gig disk, SSD. Cedric, we didn't ask you for the fancy stuff, Cedric. Normal disk is fine. And 500 gigs of transfer. So Cedric says that's going to be $4. And I'm going to be betting that you still can't do it for $4 in Burundi. Why? Why? Don't tell me it's power. Power isn't the only issue. In fact, power isn't even the biggest issue. I'll tell you. Since nobody wants to talk on this webinar, you're all very shy, I will tell you. Some of the largest internet exchange points in the world live in Amsterdam and Frankfurt. Now imagine if you were trying to run your VPS business in Amsterdam. What would you do? You would rent space in a data center because you need space for your servers. You would buy some servers, right? I don't know how many servers you need for whatever. You'd buy, say, 3 servers. You would set up your open source virtualization platform, etc., etc. And then you need to connect to the internet. Okay? How do you get connected to the internet? Well, if you're in a data center in Amsterdam, then it's really easy. You would go to one of the ISPs in the data center and you would say, hey guys, I want some transit. And there are lots of ISPs, so you can get transit easily. But because you're in Amsterdam, you would be very stupid if you didn't go to the very big internet exchange points and say, hello, I've got a new virtual machine, virtual VPS service. I want to get connected to your IX. And they will happily pay, they will happily take your money. So they will say, sure, you can get connected to our IX. And guess what? When you do that, when you get connected to the IXs in Amsterdam and Frankfurt, you're getting connected to probably half the planet's worth of routing updates. So if the routing table today is about 1 million routes, you're probably getting between 400,000 to 500,000 routes out of the Amsterdam Internet Exchange Point. And what does that do? That drives your cost of bandwidth to almost zero. Because if you can see half the planet via the Amsterdam Exchange Point, your transit costs are going to be very minimal. So why can't you do this in Burundi? Oh, your answer is going to be, well, half the planet isn't available at our internet exchange point. And my response to you is going to be something that a good friend of mine says all the time. Very simple answer. Yet. When we started this exercise in Johannesburg, I run the Johannesburg Internet Exchange Point as well. When we started this exercise in Johannesburg, running the Jinx, we started it 27 years ago. So Jinx is the oldest internet exchange in Africa. We're 27 years old today. We're older than most European exchange points, to be honest. And because we've gone through a very different regulatory experience in South Africa, our exchanges aren't as large as some of the European exchanges. But you know, we have a fair number of networks here. Today, if you connect to the Johannesburg exchange, you will see about 110,000 prefixes. So that's roughly 1/10 of the internet. And while it is not 1/2 of the internet that you would get free at Amsterdam, it's 1/10 of the internet that you would get free in Johannesburg. Now we know we still have a journey ahead of us, but we're also very, very positive about that journey, because think about what's happening in the world right now. Everybody, everywhere you look, everyone in the world is saying, invest in Africa, do this, African Renaissance, Ubuntu. I'm sure you hear all of it, right? I live in Africa. I know that Ubuntu has been happening for 20 years, but I also know that it's been getting better every year. Every year, there are more routes, there are more networks available in Africa than they were last year. And I remember, as a very young network engineer, telling my bosses 20 years ago, we need to invest in this Jinx thing. We need to do more. We need to push Jinx. We need to market it. And I remember them thinking I was crazy because, it made no sense to them. But that thing that I had in my head 20 years ago is now a reality in our environment. And so this thing that I'm trying to put in your head might not be a reality for you in Burundi this year. It might not even be a reality for you in Burundi in the next 5 years. But I guarantee you that there's only two futures, right? The first future is when the robots take over and we all go into hiding like Terminator, and none of this makes a difference, all right? And the second future is, well, the robots do not take over. Human beings continue to run the world, and we want prosperity for everybody. And so if we do, then maybe in 10 years, Burundi's exchange is going to have more than 100,000 routes. The question you need to ask yourself is, are you willing to work towards making that a reality? And are you willing to do that today? Because if you do that today, you've already seen, hopefully you understood my presentation, and hopefully you've seen that if you do that today, then the future, today you start saving money and you set yourself up for a longer future. But let's move on, because I still have more to do before I open the floor for questions. So you need a domestic IX. You need a domestic IX. You need a domestic IX that is not just running in autopilot, but a well-functioning domestic internet exchange point. And if you don't, you're always shipping capital out of your country. I like simple equations, because I think that simple equations make it easier for people to understand things. This is an equation for cost. How fast you want to go with your customers and how far you want to go with your customers is going to be a measure of the cost that you're paying. So I'm going to ask you a very simple question. How many of you think that the internet is too cheap or too expensive? Is it too cheap or too expensive? Anyone think it's too cheap and that you should be paying more for internet access? Raise your hands if you think you should be paying more for internet access. So Cedric works at Afrinic. He's paid too much money and he wants to raise his hand. He wants to pay more for internet access. Cedric is also joking. So we're going to ignore Cedric. By the way, there is one place in the world where they thought internet costs were too cheap. I didn't agree. It was a lawyer. So lawyers, have a very different version of this world. So, but here's the truth. The truth is your customers don't think that internet services are too cheap, so too expensive. Your customers always want it to be cheaper. So if we were doing simple algebra, we know that the cost, we've got to figure a way to drop the cost, right? We only have two variables. Sorry. My apologies. We only have two variables. Now, variables are speed and distance. If we want to drop cost, one or both of these have to come down. This is simple math. Who thinks the internet is too fast? Anybody think the internet is too... You want a slower internet. By the way, if you want slow internet, I can tell you lots of fun about dialing up at 2,400 bits per second and how that was not good. So I think we're in agreement that nobody wants a slower internet. In fact, if anything, we want a faster internet. So speed has got to go up, which means we only have one variable. And that variable is distance. If we want to drive down cost, which is our goal for our users, we have to figure out how do we get distance to drop. And how do we get distance to drop? Well, we shorten the distance the packets need to move to get to their destination. Whether that destination is a Microsoft cloud, whether it's a service that you need, we have to figure out how to bring either the users closer to the content or the content closest to the users. Now, if you have a solution for picking up your country and moving it somewhere else, my first suggestion would be go to the east coast of Africa because the water is warmer on the beaches. Don't go to the west coast. The Atlantic is horrible. But until you guys develop the technology for picking up your country and moving it to the east coast of Africa, you're stuck where you are. You can't move your population. And if you can't move your people, then you have to move the content. You've got to bring the content closer to you. I usually play a game. If you ever see me in real life, we can do this. I play a game where I teach somebody, where I tell you that I will bet you whatever, $100, 100 francs, whatever you want, that if you think of a number between 0 and 100, I will guess it in 7 guesses and less. Right? It's when I teach classes, it's a starting move I make. And there's always somebody in the class that says, yes, I will take the bet. Ask Cedric, we did this in Congo. There was a guy that said, I will take the bet with you. And it's not a difficult bet to win. Because when you think about the problem statement is, think of a number between 0 and 100. That's a big set. That's a lot of numbers. It's very difficult for you to imagine how can he guarantee that he's going to get that number between 0 and 100 in 7 guesses? But it's really simple. It's probably the best debugging and problem-solving technique that you will learn in your life. Take a problem and cut it in half. And if that's too big to solve, cut it in half again. And you keep doing that. You keep breaking a problem up into its smallest components until you get to it. And do the game yourself, right? Play the game yourself. Think of the number, write it in paper, ask yourself, is it between 0 and 50? No? Yes? Is it between 1 and 25? And a simple logarithmic equation will tell you that log of 100 to base 2 is what, 7? So you will always, mathematically, you will always win. So if you want a quick $100, figure out how the game works and go play it with all of your friends. Trust me, you will make money and they'll be astounded. Don't tell them how you did it. They'll be astounded. What's important about that funny game that I play is the same mechanics here. We have a difficult problem. Speed times distance is cost. But again, by dividing by 2 all the time, removing an element, we understand that the only solution we have to this is to reduce the cost of the distance. We need to bring the content closer to us. How do we bring the content closer to us? That's my question to you. But hold that question, because we're going to, well, there we go. We're going to discuss how to drive domestic content, how to attract foreign participants. This is the Googles, the Netflix, the Cloudflares, Akamai's, etc. of the world. And we have to drive down the cost to peer, right? Those are the 3 elements that we need to think about when we talk about building our future domestic ecosystem. If we want interconnection in Burundi to work, if we want interconnection in Burundi to survive, to be cheap, and more importantly, to grow, these are the 3 elements that we should be looking at figuring out. How do we deal with the domestic content and grow domestic content? How do we dolly ourselves up? How do we make ourselves pretty so that we attract foreign participants and drive down the cost to peer? We need to do this because every year, the internet doubles. On average, for the past 30 years, every 11 months, the internet grows twice. It's doubles in size. And the only way we can deal with this level of sustainable growth, we can't deal with this growth if we're going to continue to pay expensive transit costs, if we continue to pay expensive foreign exchange costs. So we need to bring the internet and its costs to levels that we can understand, to levels that we can identify with. We need to bring its costs into our local currency, and we need to limit the amount of money we're sending out of our environment, limit the cost of our transit. Now we do this through several ways. I'm going to very quickly go through this, and then hopefully we'll still have 15 minutes for questions. The life cycle that I'm showing you here is a series of things that are necessary for your domestic internet ecosystem to grow. You need an internet exchange point. You need local loops. You need fiber that will interconnect the different businesses, fiber that will allow people to get connected to the internet exchange. You need national backbones. So I don't know the cities in Burundi too well, but you need national backbones that will allow people to connect from other cities into the capital so that they can get content that might be in the capital. You would need international cables, or if not international cables, you would need international connections. So you'd need to be able to say, how do I get connected to, say, Kigali? Because Kigali is next door to you, right? Rwanda. How do I get connected to, it's Goma, right? On the left-hand side, Goma has an exchange that is growing right now. How do I get across the border into the DRC so that I can get to Goma, so that I can take advantage of the networks that are at Goma, but also get the networks that are in Goma to come peer here so that they can bring traffic to us. Critical infrastructure, you need DNS routes in your country, you need copies of .bi in your country, you need copies of other CCTLDs, etc., in your country as well. And then the thing that people don't like, policy, regulation, and governance. And this isn't about, you can't do all of this. You can't build this ecosystem if you don't have the right policies in place. You don't have the right governance regime in place. And governance regime is not about clamping down on what you do. It's about making sure that what you're doing today, you're doing for the right reasons, and you're doing to support a sustainable way of building networks into the future. Now, I won't go through these in detail. The life cycle of this entire thing, if we start with the internet exchanges, we grow the internet exchange, we develop and do all the things that are necessary. And as you do that, you find you're going to have to invest in the local loop. You're going to have to invest in backbones, critical infrastructure. By the way, critical infrastructure would also include things like carrier neutral data centers. So you have to invest in data centers in your country. The life cycle for all of this is probably about 18 months to 1 year to 2 years. And after going through the circle of making sure that you've got all of these elements that you need that fit into your internet ecosystem, it all starts again, because, as I said, the internet is always growing. So those are some of the tools that you could use. I won't discuss them. They're fairly self-explanatory, and you'll get them in the slides. But the last set of questions I want to ask you is, if you have these tools, what's missing in your domestic ecosystem? If you don't have these tools, what do you need to add? And how do you add them? And I think that BINOG is one of the great ways to start. You have an exchange, of course. Is the exchange running the way you want it? What rehabilitation is necessary? What can you do to fix it? And what help do you need? Because organizations like PCH, I'm speaking for PCH, I'm also speaking for INCS, which is the exchange sets that I run. Organizations like Afrinic, I can't speak for them, but I think I can agree that they will definitely be more than willing to help you grow, because we're all invested in making sure that the internet works better for everybody. So that's it for the slides. I know I went through the last part quickly, but I also know that we're running out of time, and I wanted to leave time for questions, because I'm hoping that there's going to be questions and we can have a nice discussion. Thank you very much. I will make sure that copies of this are sent to you in PDF. I will distribute it to Olympia and Cedric, and I guess you guys can get it from there. Perhaps I'll publish it on the BINOG website. Thank you. Are there any questions? Sorry.
Yes, I believe. The first question would be, again, regarding our IXP in Burundi. As you said, there's still a very low traffic going through it. Most of our traffic goes outside the country, and as you said, each year we are losing, the currency is getting lower and lower, and that will make us lose a lot of money. So now my question would be, what are the first steps actually? What are your recommendations? What we shall put in place now and very soon, so that actually the trends tries to change? Shall we attract the external content providers? Shall we now start to create content? And know that there's still a knowledge gap that we need to fill in order to have these content providers. We also need to digitalize our services. which are not yet digitalized. We need to have our banking system. Also, banks have their own public IPs, ISN number, which is not which is yet not available in the country. So, what would be your recommendations actually in order to work on it the soonest?
All right. So the first thing I think is when I went looking for details of your internet exchange point, I couldn't find any. I know that you had an exchange point many years ago. It was shut down very quickly. I know another internet exchange point started up after it. And I know that that exchange is working because PCH is actually a peer at that internet exchange point. But when I went looking for details of your website, let's say I was an investor, right? Let's say I was a big network and I wanted to peer at your internet exchange. Well, how would I find this? Now, the thing that most people do is they go to their favorite search engine and they say, what is the website for the Burundi Internet Exchange Point? But there's no website for the Burundi Internet Exchange Point. So that's the absolute first thing that I would fix. I would get a really simple website up and running, a website that has basically three pieces of information. Number one, where the internet exchange point is. If I was going to come into your country and I wanted to put something in the internet exchange point, I would need to know the physical address because I'd have to ship equipment. I would have to arrange for my staff to be there, etc., etc. Number two, I want to know the statistics at the exchange. Is it an exchange that's an autopilot? Is it dying? Is the traffic going up every year? That's a good indication that the exchange is working. So I would want to make sure, I would want to see the statistics, and I would want to see who's peered at your internet exchange point, which are the networks that I'm going to be able to get connected to. That's it. I mean, an IX website doesn't have to be more complicated than that. You can add a whole bunch of other stuff if you'd like, but it really doesn't need to be more complicated than that. And to get those three pieces of information into a website, if you can speak Joomla or WordPress or something like that, that's not a difficult task for anybody to do. I'm willing to bet that everybody here is better at any of those tasks than I am. You already know I don't know how to use Zoom, so trust me, I don't know how to use WordPress or anything else. But I want to believe that putting up a 3-page website is not that you don't need a project manager for it. You don't need 6 months of project deliveries and costs, etc., etc. Now, if you don't have the tools for some of that stuff, it's also very easy to get help to do that. I run an exchange in South Africa. So, we provide services to many of the nonprofits, so many of the others as well. Sarah is still here, so I'll use Sarah as an example. Sarah lives in Sudan. They run SDNOG, the Sudanese Network Operators Group. My exchange provides hosting for some of the services that they do, their mailing lists, their websites, etc., etc. So if you tell me, if you absolutely tell me that there's no way you can get hosting for a website in Burundi, then I can volunteer to host this for you. But also, I don't think that you can't get hosting for a website in Burundi. I think that you probably just haven't gotten together in a group like this and said, okay, who can provide us with hosting? Who knows how to make a very simple website with those pieces of information, where we are, how to contact us, etc., etc. Because I'm willing to put money on the table that says you have all of this infrastructure, you can do this, you just don't know how to coordinate, or you haven't coordinated in doing this. And if coordination is what you need help with, both Cedric and I are very happy to help you with that. Sarah as well, by the way.
Thank you. Yeah, but that's for to have a visibility on the IX, and then now how to drag more traffic inside of it for the moment.
Well, there's a series of tools that you would use. So for the first, you would want to have an exchange, a website, so people know where it is. And then you'd want to start to run some very basic tools, right? You'd want to have very simple tools that you can use to determine the efficiency of your internet exchange point. It's one thing to say that there's an exchange point and people are connected to the exchange point. But I can tell you this, I'm a routing geek, right? I used to spend a lot of my time looking at BGP routing information. And I can tell you that it is not uncommon for network operators in our region to have connectivity to the exchange, but completely stuff up on the BGP. So much so that even though they're at the internet exchange, traffic from that traffic isn't actually going through the IX. It's going via their transit providers or coming in or returning via their transit providers. So you'd want to have a series of tools, and these aren't difficult things. These are tests that you can use. Think tools like traceroutes, tools that you can build into the IX website. So your IX becomes a little bit more complicated right now. It's not difficult to deploy those so that the peers at the exchange can see what they are doing right and what they are doing wrong. That's not a difficult thing to do. And that's an education process, right? And part of that education process is also making sure that the networking team, as they are growing, understand what they're getting to. You can start this from the mindset. Let me give you a South African example. We have our incumbent in South Africa, who's called Telkom South Africa. And Telkom South Africa refused to work with the operators on the ground for a long time. They always believed we're the largest. And they were the largest because they were the incumbent. They got paid by the government to build the network. So of course they're going to be the largest. And they believed that because they were the largest, they didn't need to engage with the other internet service providers. A shock happened to them when they realized that, at least with the corporate market, when I was a network operator, they were not the largest network operator. I mean, the ISP I worked for had 80% of the corporate market, right? And as time went on, as our country deregulated, other networks started to build, and people want competition. People want to buy from their friends. People have their own agendas. So that we're the biggest and we're not dealing with anybody has actually dropped over time to the point where they now actually peer with people at the exchange points. The goal, I think, here, the lesson I want you to see is, if the network's here, if you are on the call and you think that you're too big to fail, or you're too big to want to work with the others, I'll tell you now, you're wrong. The one evening point about regulation, deregulation in Africa is that everybody is working and growing their networks to become bigger and larger. So if everybody is doing that, if we're all working at becoming bigger and larger, and we're all working for the same goal, which is to say, how do I bring networks into Burundi, then you understand really quickly you have to work with the other network operators. Remember the long distance, short distance thing I told you, right? This is the long path. This is the long path. Sorry, my fingers are dead. And this is the short path, the thumb. Today, you're in a situation where you're on this long path. Everything you're doing, you're bringing into your country, right? Everything that you're doing, you have to import from the outside. So even the big network operators are paying, because if they want to get to whomever in the world, they're on this long path. They don't have a choice. This long path, I need to practice this more. If you work together, you can all get onto the short path. The more networks you bring into your country, right, the more of this kind of a situation you will have, and the better opportunity for cost saving, not just the small networks, but the large networks have. I have another story I can tell you, or Cedric can tell you in a different call, because we're running out of time on this one, where I can explain to you how I live in Johannesburg. Those of you that have been here, you know it's a really big city, 25th largest city in the world, blah, 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 blah. Putting infrastructure in Johannesburg is a no-brainer. Everybody wants to have infrastructure in Johannesburg. But we've got lots of cities in South Africa. One of our cities is Durban, which is a small city. And when network operators decided that they wanted to put infrastructure in Joburg, they forgot about poor Durban, who is about 600 kilometers away. I have a fascinating story that I can tell you, and I can share with you in another time, about how the network operators in Durban got together. They created this community group, and they said, well, the network operators are ignoring us. How can we work together to get the content that is missing out of Joburg, the content that is not in Durban, which is pretty much everything. How can we get this inside Durban, and how can we save our network costs, right? How can we reduce the cost of getting, now we're talking about getting connectivity from outside of your country. The IXPs in Durban, we're talking about how do we save the costs from running 500 or 600 kilometers, because, as I said, as you grow your network, everything becomes more and more localized, and that cost saving made sense for them as well. But the truth is this, I always say, think about peering and your exchange like going on a date, right? This is pretty much something that all of us have done in our lives. When you go on a date, you're trying to impress the party on the other side. So you have to make yourself pretty, right? You have to shave. I haven't shaved, but you generally shave if you're a man. If you're a woman, you, I guess, do makeup. I don't know. Sarah is smiling at us. But you want to make yourself look good. You want to present a good picture of yourself. So my question to you is, it's great to think about the 10-step plan, but are you doing that right now? Are you presenting this good image of yourself? What does it take to move from 0 to 1? Because I've done this hundreds of times. I'm not joking. PCH works across the world. The effort and energy to move from 0 to 1 is much, much more than it takes to move from 1 to 2 to 3 to 4. So get that first thing in place first. Understand that, how do we market ourselves to the rest of the world, right? Get a good website in place, get working statistics, get very simple things working that show that you're serious about building and growing the internet exchange point, and the rest of the world will respond. I mean, if you write to me or you write to Cedric, there's no way we're going to tell you, no, we don't want to help you. And as Cedric and I are doing now with Zambia, as we're doing now with Chad, we're very happy to help you write a plan to say, these are the 10 or the 12-step process you need to do to get your internet exchange to the next level, or to get peering to the next level. There's no chance, zero chance that any of the network operators, the Cloudflares, etc., are ever going to come to Burundi and be at your IX if you don't have a website. Cedric, I don't know if you want to add anything.
Thank you.
Yes, thank you, Nishal. And I think that actually there is a lot of things that can be done when you have a working IX in your country. There are so many things that we can discuss about, like having multiple IX in the country and how it works. I won't say extension, otherwise Nishal will slap me. But there are ways to get multiple IX and make sure that you have more IX. The more IX you have in the country, and the better it is for your business. Because remember, what we want with IXPs is to make sure that we reduce the cost. Sometimes people think that IXPs will make them richer. No, the way IXPs make you richer is by reducing the cost. You spend less, so you can take that money and then this. Another interesting point with the IXP, with having a good IXP in your country, it's that behind the IXP, it's not only businesses, it's not only peering agreement, but it's also the opportunity for you to build a community. And building the community will be the best way to strengthen not only the technical knowledge, but also using the IXP as a way to showcase your expertise. I won't say to the world, but at least at a national level first, and then later on to the world, because then you have an IX, you have people working together, coming together to be able to discuss, exchange, share the knowledge. Because one rule with IXP is that we collaborate at the technical level, but we compete at the commercial level. So when it comes to the technical level, we collaborate. That's something that Nishal have put into my brain, so it's always there. So we always collaborate when it comes to technical, and if there's any competition, let's do it at the business level, at the commercial level. But when it's come to technical, let's collaborate, because it benefits all of us to have a better environment. If we have, let's say, the example of the bank, to talk about money, what me as a customer I want is to make sure that the bank that I have, the mobile app from the bank, will be fast, will respond to me when I connect, and I'm ready to change bank if that mobile app is crap. So for me, what will be interesting is if my mobile app for the bank is there locally, So it will be interesting for all the banks to come together and say, hey guys, you know what, let's make sure that we are all connected to the IXP. Then it will also be a way to force all the network operators to be connected. So which help all the country. But I will stop there, and because we are always on top of the time, and I will give the floor back to Olympe. Thank you very much, Olympe, and the BINOG crew for organizing this. And also it will be interesting, Olympe, to tell people how they can be part, how they can join. Thank you.
Yeah. Thank you, Mr. Cedric. Thank you, Mr. Nishal, for the great presentation. I've learned a lot. I'm really changed, and I believe the successful evolution of IXP and also technical community Burundi. And in order to join the community, you can just send us an email to contact@nog.bi. Just a simple email, contact@nog.bi, and we'll be very, very pleased to add you and on the email communication as well as on WhatsApp group, and just do that request. And I believe everyone who also joined the webinar has learned a lot in terms of how internet works, the economy of internet, how one can get to know how to improve the profit by internet service provisioning and stuff. Yeah, that's it. And I hope we are going to continue with more upcoming series of webinars, more knowledge exchange, and also development of our country. Yeah, thank you very much.
Thank you. Maybe if, oh, Nishal, you are muted.
Oh, sorry. I was just saying thank you for the invitation. I know that this is probably not what some of you thought it would be when we started talking about internet exchanges. But as I always say, understanding what you're trying to do is important when you understand what you need to do. You know now why you need IXs. Now it's the what do we need to fix, and those are really small, right? That's simple things like the exchanges, the website, but also other things like skills transfer, technical knowledge, learning BGP, etc., etc. That I think is equally important, and that's also part of what should be the next step. So I'm hoping that the NOG team, you're going to arrange BGP training, etc., coming out of this. And as I said, if you need assistance, let us know. Thank
you very much. And also, I'd like to tell the other community that they can reach us on Twitter, BINOG, just look for BINOG, and also on LinkedIn. And we are going to record this. This has been recorded, and then we'll be able to share it on YouTube. Links will be on Twitter as well as on LinkedIn. Yeah, thank you very much, and really eager to hear more upcoming events with the BINOG.
I think maybe before we finish, two things. One, this is just the first, as Olam said, this is just the first series of webinar that we want to organize for the BINOG. But one of the goal is actually to have a face-to-face event. We want, we are in Africa, we want to shake hands, we want to see each other in the eyes, and so this is the plan is to have something, let's say, before June to have an event. So we will still run some few webinars in the meantime that we finalize this. We are really blessed to have support from multiple people, including the CETIC. For those who knows, the CETIC is they are part of the Minister of ICT, Olympe, if I'm right.
Yes. In French, that's Secrétariat Exécutif des TIC au Burundi. Yes. So that's in short the direction of ICT policy implementation and projects in Burundi. So they were the ones that actually implemented the fiber optical ring in Burundi. They are the ones actually managing the IXP. They are the ones also help the universities to be connected to Ubuntu Alliance. So they are managing all these services in Burundi and also upcoming projects. Yeah.
Yes, thank you. So that was my first point. And second point, please, if you can put your camera on, we just want to take a picture for the BINOG website. So if you can, if you have the possibility to turn on your camera, just want to take a quick picture. Okay. Okay. I assume that the rest are not, they are still putting their makeup. Okay, so let's say everybody ready? 1, 2, 3. Done. Thank you very much. Oh, let me take another one. Okay. Oh, there are more people coming. So let me take again. Okay. Thank you. Thank you very much. And
Thank you.
And see you guys for the next webinar. And thank you again, Nishal.
Thank you very much. Shukran. Bye.
All right.
Bye.
Bye, everybody.
Bye.